All right, let's take a look at your worksheet 5.5 on inverse functions. Inverse functions is when we are in essence interchanging the x and y values and writing a new function that will basically undo our original function. So in number 1 here it says a function f of x contains these 4 points. Give the points to be known as the inverse. So when you're given a simple list of points, the inverse is just flipping. You're just flipping the x and y values. So instead of having -2, -3, we now have -3, -2. And then we have the point -1, 0. And then we flip the next set of points, 2, 2. So it doesn't look like it's flipped, but it actually is. And then we have the last coordinate now at 6, 4. And that's it for number 1. Number 2, given the function g of t equals 5 plus 2t. So when we want to find the inverse of this, how we do it algebraically is first, we replace the g of t with y. Find it's easier that it's in terms of x and y for students. So, or in this case, t. So if it helps too, you can replace the t with x, but I'm just going to leave it as t. We're going to flip now the t and the y value. So t equals 5 plus 2y. Now, to get the inverse, we solve for y. So subtract both sides. So t minus 5 equals 2y. Divide by 2. You got y by itself now. T minus 5 over 2. That's your inverse function. So g inverse of t is equal to t minus 5 all over 2. Now, using both g of t and g of negative or inverse of t, we want to find these specific values. So find g of 2. So to find g of 2, we go back to this particular function, or the first original function, replace the 2 with t. So when I do that, I get 5 plus 2 times 2, 5 plus 4, so g of 2 is 9. Now we want to find g inverse of 9. You're going to see something interesting here. So I'm plugging this one now in the inverse function. So I have 9 minus 5 divided by 2. Well, 9 minus 5 is 4. 4 divided by 2 is 2. So g inverse of 9 is 2. Think about this. When you plugged in 2, you got 9 in the previous function here. So when you plug it into the inverse, it brings you back to 2. So g inverse of 20, just to get more practice plugging it into the other function, 20 minus 5, all divided by 2, that would give you 7.5, because 20 minus 5 is 15, 15 divided by 2, 7.5. That's your answer to D. All right, number 3, a little bit more challenging. It says, which graph below shows the inverse relation shown on the graph to the right? Sometimes it's hard just to see what the inverse actually does. How do you know? Remember that you interchange the x and y values, or it's a reflection over the line x equals y. The reflection is a little bit harder to see. I find it's easier for students that knowing that you're interchanging x and y. So what I do is I take the original function here and I take a look at where are these original points. Here's the original xy. So this one coordinate here, this first coordinate up top, is located at, looks like it's at -3, 2. The next point down here is located at 0, -1, and then at 2, -1, and the next one's at 3, 0, and the last point is located at 5, -2. To find the inverse, just like we did in number 1, flip them. So now our new points should be at, and this would be the inverse. So are now going to be located at 2, -3, -1, 0, -1, 2, 0, 3, and -2, 5. So see which points start that way. So I'm going to look at the point 2, -3. Well, 2, -3 is right here. Can't be A. 2, -3 is right here. Can't be B. 2, -3 is right here. So just to keep on checking, -1, 0, -1, 0, -1, 2, 0, 3, -2, 5. Look at that. C is our winner. Excellent. All right. Next up here it says the function 3 plus 2x is graphed to the right. Accurately graph the inverse on the same graph. So I'm going to take the function f of x equals 3 plus 2x, replace the f of x with y, then I'm going to interchange the x and y's. So now x equals, whoops, I apologize, I forgot the x there. So x, going back now, x now equals 3 plus 2y. Solve for y. So I have x minus 3 equals 2y. Those cross out, divide both sides by 2. And I got my function, x minus 3 all divided by 2. So now I want to accurately graph this function. So the inverse of f of x is equal to x minus 3 all over 2. So I just need some points to graph this equation. So let's just pick some values for x, and then we'll have the f inverse of x. So let's let x be some odd numbers since we're subtracting 3. So let's have it be like 5, 3, 1, -1, -3, and -5. That will give us plenty of points. 5 minus 3 is 2. 2 divided by 2 is 1. 3 minus 3 is 0. Anything divided by 0 is 0. 1 minus 3 is -2. -2 divided by 2 is -1. -1 minus 3 is -4. You're starting to see a pattern here. So I'm going to graph those points. 5, 1. There's 5, 1. 3, 0. 1, -1. -1, -2. -3, -3. And -5, -4. Here's my f inverse function. F inverse of x. There it is. Excellent. That takes care of page 1.